Hello friends, in this video I am going to discuss about phase shift by feedback network in oscillator circuit. Okay, so in our previous video we already have discussed the Barkhausen criterion, and those criteria are basically this is number 1 and this is number 2. If you want the clarification, you can check my previous video. So we got these two very important result, that is the magnitude of product of open loop gain of the amplifier, that is AF, and the magnitude of the feedback factor, that is beta F, should be unity. So basically what I mean to say by this concept, that is a mod of AF into beta F, that is basically equal to 1. Clear? And the total phase shift around the loop should be 0, or it may be multiple of 360 degree. So what it means, that angle AF into beta F should be equal to 0 degree or 360 degree multiple. Clear? Because if this satisfies, that means there is no phase shift basically. Okay, so why we have got these two conditions? To make one amplifier a oscillator, we require these two conditions. Because suppose there is a block, we apply only VCC or DC input voltage, and if we want a oscillation, then obviously we have to give make these two conditions satisfied. Okay, because the overall loop gain, that is AF into beta F, must be equal to 1, and from that we derive these two conditions. This you know. Now in this video we are going to discuss about phase shift by feedback network in oscillator circuit. What we know from Barkhausen criteria, that is if you make one complete loop, that means if you move in this way, then obviously the total phase shift of a complete loop is 0 degree or 360 degree. Now what is the amount of phase shift offered by the selective network beta, frequency selective network beta? That thing I will discuss. So see, basically there are two types of amplifiers, I can say. Suppose you apply input in this side, left hand side, you get output in the right hand side. We say that this amplifier is inverting when suppose you give one input which is starting from the positive half cycle like this. If you apply this input and if you get amplified output, but it is with 180 degree phase shift, then that is called inverting amplifier. Okay, so basically for this type of inverting and basic amplifier block, there is 180 degree phase shift. Clear? So suppose here we are applying the input for inverting amplifier. Clear? Small input is applied and we are getting large amplified output but with 180 degree phase shift. So that means there is 180 degree phase shift offered by the basic amplifier block, but I have to make the overall phase shift as 360 degree or 0 degree. That means no phase shift should be there. So as this amplifier block is providing 180 degree phase shift, so in that case, for inverting amplifier case, the selective network, the frequency selective network must provide 180 degree phase shift. Then only 180 degree plus 180 degree, as a result here the signal will have basically 360 degree phase shift with respect to the Vs. Okay, so for inverting amplifier, the must satisfied condition is that the frequency selective network must have 180 degree phase shift in between its input and output. Can you give one example where this condition must be satisfied? Yes, that is CE amplifier. I already discussed that for CE amplifier, the phase difference in between input and output of the basic amplifier is basically 180 degree. Why that phase difference is there? You can check my previous video. or although I will give you the link in the description of this video, you can check from that. So basically for CE amplifier, there is 180-degree phase shift in between input and output. So if you want to make total 360-degree phase shift, then obviously if you want to make one oscillator with help of CE amplifier, you must have to make or design such a frequency selective network which has 180-degree phase shift minimum. Why? Because it has to satisfy 360 degrees. So 180 degree if it is done by the basic amplifier, then obviously the rest 180 degree must be done by the frequency selective network. Clear? And this is one type of basic amplifier which is called inverting amplifier. There is another type of amplifier which is called non-inverting amplifier. So what is that? Suppose this is non-inverting amplifier. So what happens in case of non-inverting amplifier? Suppose you give one very small input signal, we get a large output signal, but there is no phase difference in between input and output. That means input and output signal are basically in same phase. Clear? Now suppose you apply the non-inverting amplifier in the oscillator case. What will happen? Suppose you don't apply CE amplifier, you apply such an amplifier which has no phase shift in between input and output. So what can you do? See, that means when you apply the input here, what you get at the output side, I will show you by another color. For non-inverting case, I will use black color. Sorry. So suppose here you are applying this input signal, then obviously for non-inverting case, what you will get? This you will get as the same phase signal. Okay, this is for non-inverting. The black one is for non-inverting basic amplifier. Now see, as the phase shift offered by this basic amplifier, that is AF block, is 0, basically. Clear? So basically to maintain total phase shift 0, obviously the frequency selective network must provide the phase shift of 0 degree. Then only 0 degree plus 0 degree will become 0 degree. That means no phase shift. Our target is overall phase shift should be 0 or multiple of 360 degree. That means no phase shift in between input sector and output sector. So if we apply non-inverting amplifier, then obviously we have to design such a frequency selective network which will provide 0 degree phase shift. That means no phase shift in between the input of the feedback network and the output of the feedback network. Clear? So make a clear concept in this portion. This is very important concept for oscillator. Every time it will help you that for an inverting amplifier, the feedback network provides a phase shift of 180 degree. Okay, why 180 degree? Because already inverting amplifier, basic inverting amplifier is providing 180 degree phase shift, and one more 180 degree will be phase shift. One more 180 degree phase shift will be done by the feedback network, so that total will be 360 degree. While for non-inverting amplifier, the feedback network provides a phase shift of 0 degree. Why? Because already the basic amplifier for non-inverting case is providing 0 degree phase shift. So obviously to maintain total phase shift as 0 degree, the feedback network must provide phase shift of 0 degree. Okay, this is very important concept for oscillator discussion. And one more result we got, that if we apply CE amplifier as basic amplifier block in oscillator, then we know that for CE amplifier 180 degree phase shift is there in between input and output. So obviously we have to design the feedback network in such a way that it will provide 180 degree phase shift. Okay, I am forcing on this line. Why? Because most of our discussion on oscillators are basically done on the CE amplifier by assuming the basic amplifier block as CE amplifier. Okay, because discussion of CE amplifier is quite easy, because you already have studied all the concepts related to CE amplifier in frequency response, biasing, transistor operation, everything. So most of the case we deal with CE amplifier in oscillator module. Okay, so you remember, if you use CE amplifier, then you have to design feedback network in such a way that for feedback network there must be 180 degree phase shift. Then only it will satisfy the Barkhausen criterion, second criterion. So that we can get the oscillation. Okay, so this is all for this video. I hope I have made a clear concept in this part. If you have any doubt regarding this, you can ask in the comment section. I will try to give you the answer. Okay, and if you find this video helpful, please like, share and comment. And for more videos related to oscillators and other portions of electronics and communication engineering, please like, share and comment and subscribe my channel, and don't forget to press the bell icon. Thank you for watching.